Yeah, hi everyone. My name is Ravi Prakash and welcome to practice class of geometry. Okay, so we'll start with this question. We'll do some fantastic questions in these few practice classes. Very important concepts we'll do. Okay, this is very important one. This is very good question. Okay, just see this question here. One of the sides of an obtuse angle triangle uh, of perimeter 180 centimeter is 80 centimeter. Okay, so it is an obtuse angled isosceles triangle. Okay, so obtuse angled isosceles triangle of perimeter 180 centimeter is 80 centimeter. So it is one of the sides. Okay, what is the distance between incenter and circumcenter of this triangle? So we'll solve it. See, now say since it is an obtuse angle triangle, so we know the condition for obtuse angle triangle, right? What is the condition for obtuse angle triangle? It was longest side is square, right? If you remember, we did this. Longest side is square should be greater than sum of squares of other two sides. Longest side is square should be greater than sum of squares of other two sides. Okay, this is the condition for obtuse angle triangle. So if one side of a triangle is 180 centimeter, right? If one side is 180, if perimeter is 180 centimeter and one side is 80 centimeter, we can have two information from here, right? What is the first thing? The first thing we can have is, see, the first thing we can have is a triangle with side 80, 80 and 20, because if one side is 80 centimeter, so it's an isosceles triangle, right? So two sides are equal. If one is 80, so other would also be 80. This is one case, okay? And second case is this one. If one is 80, then rest two will be, right? Rest two are equal, no? So if one is 80, so 100 is left. So 100 is left. So 100 will be divided as 50 and 50. Okay. So again, that means one side is 50, this side is 50, and this side is 80. Okay. So these are two cases. So 80, 80, 20, 50, 50, 80. Fine. So you'll see here, longest side is square should be greater than sum of squares of other two sides. That means this obviously here 80 square is greater than 50 square plus 50 square. In second case, it is true. Here 80 square will not be greater than 80 square plus 20 square. It becomes false, right? This is not true. That means sides of our triangle are 80, 50 and 50. Okay, so very important information. Sides of our triangle are 80, 50 and 50, right? Now we'll solve it. Okay, so sides of our triangular that we got here is 80, 50 and 50. Correct? Now let's make it. So a triangle with 80, 50 and 50 sides. Okay, the triangle with this is 50. Yeah, this is 50, this is 50 and this is 80. So in isosceles triangle, the base is the 80 here. So if you drop a perpendicular here from here, okay, so we read it, this perpendicular acts as median as well as the height of triangle. That means this will become 40, this will become 40, it is 80 was its full number, okay, this full length, this 40 and 40, if it is 40, it is 50, so by Pythagoras theorem, it becomes 30, right, it becomes 30, right, so this is 30, 40 and 50. So to find incenter and circumcenter. So for finding incenter, area is equal to R into S, that we know. Okay. So what is the incenter of this triangle? Where is the incenter of this triangle lies? Okay, area equal to R into S. What is area here? Area of this triangle is what? Half into base into height. So height is here is 30, base here is full 80. Okay. So half into 30 into 80 is equal to R into S. What is S here? Same perimeter. That is half of 180. Same perimeter is half of 180, right? So half of 180, that is 90. So we got here. This will be 9. Yeah, sorry. This will be 90 here. So this will be 90. This is 30. This will cancel out 33 times. So we got our R is equal to R is equal to 160 by 3. That is 53.33. Okay, so in radius is 53.33. Right, you get this point here. In radius is 53.33. Okay. So if in radius is 53.33, what is now circumradius? We can also calculate circumradius, right? We can also calculate circumradius. So for calculating circumradius, we'll calculate again area is equal to ABC by 4R. Correct? ABC by 4R. Okay. Notice area here, we got area same thing here. Area is half into 30 into 80. ABC are the 4 sides. That is 80 into 50 into ABC has the 3 sides, 80, 50 and 50 upon 4R. Okay, now I can cancel here. Okay, this comes to 15, right? Now, cancel out 25 and 25 with 2. So what we are left here is R is equal to 25 into 25 by 15. Further I can cancel 5 by 3. It becomes 125 by 3. Okay, so R becomes 125 by 3. That is 41.66. So circumradius becomes 41.66. In radius becomes it is 50. Sorry, not some caption mistake I've done here. I think. Yeah, I'm sorry. 160 by 3. 160 by 3. It will become not 160 by 3. 80. It becomes 40 here. 40 by 3. So it becomes not 160 by 3. It becomes 40 by 3. That is 13.33. Okay. So some caption mistake. Okay. So R is equal to 13.33. We got. Capital R is equal to 41.66. We got this here. Okay. So now observe the situation here. We got small r is equal to 13.33 and we got capital R is equal to 41.66. Okay. So we'll observe what is this case here. Okay. We'll observe what is this case here. Okay. See the next slide. See. Capital R we got as 13.3. So small r, that is in radius, we got as 13.33. Capital R we got as 41.66. Correct. Now this is a triangle here. Observe this is a triangle here. Okay. This is a triangle. So triangle ABC. This is a triangle ABC here. So R is equal to 13.33. Fine. So see. First we'll draw all this 50. It was 50. We draw a perpendicular. It was 40 and it was 40. Okay. So this somewhere here it would be circumradius is basically distance of circumcenter from the vertex, right? Circumradius is distance of circumcenter from the vertex. Okay, this is a vertex here. Suppose this is a vertex A here. Okay, this is a vertex A. So from here it is at a distance of 41.66. So since this is 30, so obviously it will go beyond it, right? So they name this as AD. It will go beyond AD. So 30 and plus 11.66. So let's say this is the circumcenter. Okay, let's say this is the circumcenter C and this length is 30 plus 11 point. It should be 11.66 to make it full 41.66. Correct. What is in radius? In radius is 13.33 here. What is actually in radius? From incenter, it is distance of the perpendicular drawn from the vertex on that side, right? If you remember in radius, in circle, this is in circle. This is in center. What is in radius? Length of this perpendicular drawn. This is in radius. Okay. So in this case, this is a perpendicular drawn here. So let's say that somewhere in center would be here, I. Okay. And it is at a distance of 13.33 from the D. So this distance is what? This distance is 13.33 from D. This distance is 13.33 from D. Okay, this is 13.33. So our total question was, what is the distance between incenter and circumcenter? So incenter and circumcenter, that length is distance between I and C I want. So it is visible, it is here 13.33 plus 11.66. Okay, 13.33 plus 11.66, it becomes 25. Okay, that is 13.33. Distance between incenter and circumcenter is equal to 13.33 plus 11.66. That is 25. So 25 is the answer. Okay. It should be 24.99, but we have assumed actually it was 125 by 3 and 41 by 40. This is 60 by 3. This capital R was 125 by 3 and this small r was 40 by 3. If you calculate actually in fractions, not in recurring decimal, you get for 25 only, right? 13.33 plus 11.66, that is 25. So 25 is the answer. Very good question. Very good conceptual question it is. Okay. Now we'll do next question. Okay. So this is the next question here. In this question, we'll see this OA and OB are the tangents to the circle. Okay. And OB is equal to 204 and AB is equal to 192. Okay, AB is a straight line joining this point of contact of the tangent here. So AB is equal to 192, OB equal to 204. We need to find the length of radius of the circle. Okay, so radius means I need to find it, just join AP. So I need to find the length of AP here. Okay, so how to find it? Okay, so see how to solve. Very good question. It's a very nice question. How to solve it here? So we have studied the concept of kites in circle. Okay, we have studied the concepts of kites in circle. So kites in circle basically what? Two tangents and two radius in a circle always forms a kite, right? We did this. See, there's a circle here. So two tangents and two radius in a circle always forms a kite. There's a center here. Okay, just let's say OA, OB are the tangents. If I join P, so PA, PB are the radius. So it is a kite because PA and PB are equal because of being radius. OA is equal to OB because of being tangent. Okay, so OA equal to OB because of being tangent, right? So it follows the properties of kite. So what are the properties of kite here? So we have learned it. If I join AB, that is a shorter diagonal of the kite. And if I join OP, that is a longer diagonal of the kite. Okay, so in this case, this let's say this point is Q here. This AQ is equal to QB because we've studied it. Longer diagonal in a kite bisects the shorter diagonal. Longer diagonal in a kite bisects the shorter diagonal. Okay, that means this is PA. Okay, this is a radius. If I join this PB here, it is also radius. So I can write here that OAPB forms a kite, right? OAPB forms a kite. And to write this here that OAPB forms a kite. So if OAPB forms a kite here, so to follow all the property of kite. So AB is the longer diagonal of this. AB is the shorter diagonal of this kite, and OP is the longer diagonal of this kite. Okay, so if AB is 192, so we just studied that longer diagonal bisects shorter diagonal at 90 degree. This is a property of kite. Okay, longer diagonal bisects shorter diagonal at 90 degree. Okay, bisect means these two will be equal. So if whole is 192, so half of it, right? So half will be 96. Okay, and then we also know that from a point, length of both the tangents drawn on this circle are equal. That means OB will be equal to OA. So if it is 204, this also becomes 204. Correct? Okay. So now we need to find the length of here this AP or BP. Anything I need to find the length here. Let this point of contact be here X. Okay, this is X, and this is also 90 degree because radius and tangent always makes an angle of 90 degree. So how to find the length of BP? There could be many ways of finding, right? But I'll use the fund of similarity because we studied it. Similarity, if you remember, see PB. If I draw this red triangle outside, okay, to make it clearly visible, there's a triangle here. So this is P. Okay, this is X. Okay, this is B. This is O, this is 90 degree, and this is also 90 degree. Okay, So basically, it is a right angle triangle PBO and BX is a perpendicular. So again, this is 90 degree. So you can use funda of similarity, that right angle inside a right angle triangle. Okay, so we have studied it, both the triangles are similar. If you take any three pairs of triangle here, right, both a small one, okay, or one bigger one and one is small, this is small one, and one this bigger one and this is small one. Okay, so all three pairs of triangles are similar here. We have studied this. Okay, so what I'll do here is for finding the length of this BP, I'll use funda of similarity. Okay, so we know that triangle PXB is similar to triangle XBO. Okay, we write on the basis of angle, we don't write on the basis of here order here, PX and XB and XB and XO, right? So it doesn't matter whatever is the order, right? Because we studied similarity on the basis of angles, not on the basis of this ordering of this PXB or sides of or the vertex of this triangles. Okay, so it doesn't matter here. So this PXB is here, XBO is here. Okay, so what to do? Assume any one angle as theta. This is 90. This becomes 90 minus theta. Okay, and this is whole 90. This becomes theta. This is 90. This is theta. This becomes 90 minus theta. So that's why I've written this. Both the triangles are similar because of AA similarity. For AA similarity, we need only two angles. Okay, but here all three angles are equal. That's a plus point for us. So these two triangles are similar. Okay, so these two triangles are similar. What length is known? This length is 204. Fine. Okay, what is this length? This length is 96. Fine. So by Pythagoras theorem, okay, this length is 96. This length is XB is 96. Okay, this XB is 96. XB is 96. So XB is 96. Okay, this BO is 204. We need to find the length of OX. This we can do by Pythagoras theorem. Okay, but directly we can do. We don't need to do that much also. We know that what is the ratio of sides here? 204 is the hypotenuse. So 204 is to 96. What is the ratio of sides? If you cancel out, 12 will go 8 times here, 12 will go 17 times here. So this is the ratio of sides is 17 is to 8. Okay. So if you remember Pythagorean triplet, it's quite easy. If this is 17, if this is 8, this has to be 15. Okay. Because Pythagorean triplet, so do it very fast. Okay. 17, 8 and 15. Or if you got these two as 17 and 8, by Pythagoras theorem, this will get XO as 15. So you'll get this OX as 15. XO or OX as you will get as 15. Okay. So once you get this 15, what is the multiplying factor for this triplet? So it is 8 into 12, 96. It is 17 into 12, 204. So it will be 15 into 12, it will be 180. Therefore, OX is 180. Okay, OX is 180. OB is 204, XB is 96. In this triangle, it is not known. Okay, so we'll calculate. This BP is the radius. This we need to calculate. This BP is the radius of the circle. BP is the radius of the circle. This we need to calculate. Okay, so now let's do it. 17, 8. Okay, now, so if these two triangles are similar, now, so take any angle. So we need R here. So if I need R here, I'll pick 90. If I need R here, I'll pick 90. Here, in this triangle, 90, in triangle PXB, 90 opposite is R. In triangle XOB, 90 opposite is 204. So ratio becomes R upon 204 is equal to. One more you take. So you have to pick from this angle, you have to pick 90 minus theta. You won't pick theta because theta opposite is not known. So what you will pick? You will pick 90 minus theta. So if you pick 90 minus theta, in this triangle, 90 minus theta opposite is 96. And in this triangle, 90 minus theta opposite is 180. So it is 180. Yes, the question is solved now. Okay. Then simply cancel it out. So 12 will go 15 times. 12 will go 17 times. Okay. Now 96 by 15, cancel by 3 here. 5 and this will be 32. So R becomes 32 into 17 by 5. If calculation mistake is not there, so I hope it is correct. Okay, 17, 15. Yeah, fine. So 32 into 17 by 5. So if you solve it, double it, divide by 10. So if you double it, 32 into 34. So 32 into 34 is how much? It is 33 square minus 1. So 1088 by 10, it is 108.8. That should be the answer for this question. Okay, so sorry. Yeah, fine. This should be the answer for this question. Okay. So I hope you got it. So this was a very good question. Two tangents of circle were given. We need to find the length of radius of the circle, where this AB was given as 192 and OB was given as 204. So what we did, we just joined this AB and it becomes APBO or OAPB becomes a kite. We know that in any circle, two tangent and two radius forms a kite. It will follow all the properties of kite. So most basic properties of kite is longer diagonal bisects shorter diagonal at the at 90 degree. Okay, so here longer diagonal is OP, shorter is AB. It bisects AB at 90 degree. So AB was 192, it becomes 96. Then we applied Pythagoras theorem to find the value of OX. Okay, we got it as we got it as 180. Then we applied, since both triangles are similar, we applied the funda of right angle triangle inside right angle triangle. We have studied this in geometry many times. Okay, right angle triangle inside right angle triangle. Okay, so this we applied similarity and we got the value of R formula. Okay, so I hope it is clear. Okay, see you in next question. Thank you.